In the name of Allah Almighty, who is the most merciful and beneficent. Assalamu alaikum. My name is Safanuddin and I am from Biotechnology Department. The topic which I am going to present is how to test permanent water hardness. So let's get started. What is hardness in water? Hardness in water can be defined as the amount of calcium and magnesium in water. In addition, high amount of other minerals are also dissolved in water, but the quantity of calcium and magnesium is higher than those minerals. The pH of hard water is about 8.5. A question arises here, what is pH? So a pH is a measure of how acidic or basic the water is. pH less than 7 indicates acidity, whereas pH greater than 7 indicates a base. Types of water hardness. There are two types of water hardness, permanent water hardness and temporary water hardness. Temporary hardness is due to the presence of carbonates and bicarbonates of calcium and magnesium. When we boil water, temporary hardness can be removed easily. On the other hand, permanent hardness cannot be removed by boiling, and it is due to the presence of sulfates and chlorides of calcium and magnesium in water. Moving towards the next slide from where the main part of my presentation starts. Testing permanent water hardness by EDTA method. Ethylene diamine tetraacetic acid is an amino polycarboxylic acid. Here is the structure of EDTA. In the center there are two nitrogen atoms and there are four COOH groups. It forms a complex with calcium and magnesium ions. It is basically a chemical. It is basically a chemical that binds certain metal ions such as calcium, magnesium, lead, and iron. This is a type of settling agent. Agent is basically a chemical compound that binds tightly to metal ions. So, if we want to determine the permanent hardness in water, EDTA is the easiest way. It can react with all the metals except alkali metals. Ions like strontium, iron, barium, and manganese also present in hard water. Next, have a look on apparatus. It includes conical flask, funnel, burette, stand, beaker, pipette, graduated cylinder, hot base stirrer, watch plate, spatula. Chemicals include buffer solution, inhibitor, iriochrome black tea indicator, which is present in blue color, sodium hydroxide, standard EDTA solution of 0.01 molar, magnesium sulfate. Buffer solution is basically an aqueous solution consisting of a mixture of weak acid and its conjugate base or vice versa. On the other hand, inhibitors can decrease the rate of chemical reaction or it can stop the rate of chemical reaction. In procedure, uh, we have in procedure we took 50 ml of water sample into a conical flask, then added 2 to 3 ml HCl and boiled for 2 minutes. Cooled the solution and neutralized with the dilute sodium hydroxide, then added 1 to 5 ml buffer solution. The pH should be 10. Check the pH with standardized pH meter, and we can also add inhibitor after the buffer solution. As I already told you, inhibitor can stop the chemical reaction. Then added 2-3 drops of EDTA, which forms a complex with magnesium, 0.1 molar solution, and 3 to 4 drops aerochrome black the indicator. Then shake well and the color becomes wine red. Fill the burette with standardized 0.01 molar EDTA solution. Recorded the initial burette reading and titrated the water sample with this standard solution. At the end point, the color of the solution turns into the blue from the wine red. Titrated carefully near the end point. Repeated the titration process at least 3 times for accuracy. Here are the calculations of this experiment. These are all the spores values. Um, Adding the reading of endpoint and divided by the 3. Adding these 3 readings and then divided by 3. We get the average and we get 20.0 ml. The permanent hardness can be calculated by using the following formula. 1 ml 0.01 molar EDTA is equal to 0.001001 gram of calcium carbonate. We can also use it in the milligrams. In milligrams, in milligrams, 1 ml 0.01 molar EDTA is equal to 1 milligram of calcium carbonate. As x ml, we are talking about this reading 20. 0.01 EDTA is equal to 20 ml multiplied by 0.001001 gram calcium carbonate, and we get 0.02002 gram of calcium carbonate. The 50 ml water sample is equal to 20 multiplied by 1.001 milligram of calcium carbonate. In the previous one, we used it in milligram. Now we are using it in milligram. And we get 20.02 milligram of calcium carbonate. As 1000 ml of water sample is equal to 20 multiplied by 1.001 multiplied by 1000 divided by 50, and we get 40 milligram of calcium carbonate. Now multiply 20 with 1.001 and 20 ppm of calcium carbonate, and we get 400.4 ppm. These all are supposed values. In the result, we have the amount of permanent hardness present in the given water sample is equal to 400.4 ppm. So in this way, we can determine the permanent hardness in water. Thank you so much for your attention. Have a nice day.